So in 6.4, we've learned the other two methods, or other two shortcuts to proving that triangles are similar, which are what? What are the new acronyms, Emily? Side, angle, side. And? Side, side, side. So side, angle, side says two pairs are proportional, and the angle where they meet are congruent, right? And then side, side, sides, all three sides. So number 1 says verify that triangle ABC is similar to DEF for the given information. So if you want to make yourself a little picture, then go for it. So ABC, DEF, and the information that they give you is AC is 6, AB is 9, BC is 12, DF is 2, DE is 3, and EF is 4. So we know nothing about the angles, which means you're going to rule out angle, angle, and you're going to rule out side, angle, side. The only option you've got is side, side, side. So I'm going to put the smallest in the top one, which is 6, over the smallest in the bottom, which is 2. And then the middle one would be 9 over 3, and then the last one would be 12 over 4. And if these all reduce to be the same thing, which they do, then that's our verifying. So we're showing that each of those proportions would equal each other. If it asked why, then my answer would be side, 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 similarity.
Does it matter which way?
Nope. Nope. So you could have flipped it and had them 1 to 3 and 1 to 3 and 1 to 3. As long as you're showing that all three side lengths, when reduced, would equal each other. Okay, then the next one. 2 says show that the triangles are similar and write a similarity statement and explain your reasoning. So now I've got 2 sides of each in an angle. Are my angles congruent? So angle Y equals angle B, and XY, or 30 over 45, would have to equal, 30 over 40, would have to equal 45 over 60. So this goes 3/4, and 15 goes in each of these 3/4. So the similarity statement is which triangle is similar to which triangle. So if I say X, Y, Z, then the order of the letters of the other triangle have to be what? A, B, C. And explain your reasoning. This would be side, angle, side, similarity. Questions on that? Okay, so we're going to go right to the notes, and then at the end you'll have time to work on the homework. So 6.5 is the last section that we're going to cover in the chapter. Last section that will be on your test, and last section that will be on your midterm. So 6.5 is called using proportionality theorems. So you're going to learn a couple more theorems in this section that somehow deal with some sort of proportionality. Some of it is with triangles, and some of it is with parallel lines, but they're all proportionality. So the first one is the triangle proportionality theorem that says if a line parallel to one side of the triangle intersects the other two sides, then it divides those two sides proportionally. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So if I had a diagram like the one that's there that says BE is parallel to DC, so that's a side that is parallel to one side of a triangle and intersects the other two sides, that EB intersects AD and AC, then it divides those two sides proportionally. So I can say that AB over BC, so I did the right side of the top and then the bottom side, would equal AE over ED, left side of the top over left side on the bottom. I could have also said AE over AB would equal what? So if I go left, right on the top, then I have to follow that pattern, which would be what on the bottom? ED over BC. So basically what happens here is we have now made these triangles similar, right? Because if they're parallel, I have the angle at the top. Everybody sees that, right? I've got that one pair of angles that are congruent. And then if these are parallel, then this one matches this one, and this one matches this one. But I didn't even need both pairs. I only needed one other pair. Those triangles are similar. And if the triangles are similar, then their sides are proportional. So that's kind of where we get to here. But you don't need all that stuff in between. All you need is that those lines are parallel.
Wait, what is it?
So you can rearrange it in a lot of different ways. I can go top, bottom, top, bottom. I could go left, right, left, right. Right, left, bottom, top. So as long as I'm consistent on one side, so I went AE, which is the top left, and then so I'm going left, right. I don't know if that makes sense. Like I went left, right, so then I can go left, right. I could follow that pattern. Okay, I could go AB over AE, so now I'm going right, left, would equal BC over ED, which is right, left. As long as I'm consistent in my pattern, it doesn't matter. Okay, the converse of the triangle proportionality theorem. Converse flips the order, right? This says if a line divides two sides of a triangle proportionally, then it's parallel to the third side. So now we're switching the if and the then. The if is now that the sides are proportional. If that's true, then the lines are parallel. So if the sides are proportional, and I've got the angle at the top that's congruent, these two triangles are similar because of side angle side, similarity. And if they're similar, then those two angles are congruent, which makes the lines parallel. So it's kind of working through all that for you. So if AB over BC, so I went top right, bottom right, equals top left over bottom left, AE over ED, or not equals, sorry, is proportional to, then these lines are parallel. All right, so you've got a triangle, and on this triangle are two segments that are marked as parallel. You see those little teeny tiny arrows? Okay, so if they're parallel, then the segments are proportional, and CD over DA would equal what? CE over EB, or BE, you can write either way. If CD is 3, and DA is 6, and DE is 3.5, then what's AB? So now we're working with the proportional triangles, right? This over this should equal, actually that over the whole side. So this is dealing with the similar triangles actually, right? So this over the whole right side of the triangle is going to equal this over this whole side. So 3 over 9 would equal 3.5 over x. So the difference with this one is that it's dealing with the top or the bottom of the triangle, not the part that's divided into parts. So I'd have to cross multiply here. 3x would equal 3.5 times 9, so 1.5. 27, yep, 31. And then divide by 3. And then let me clear that off. C says if CB is 12 and EB is 8, CD is 6, find DA. So now I'm dealing with my proportion side. So I can break these up into parts, okay? So if I have 8 and x, right, if I go left to right and I have 8 and x, what would go over 6? How'd you get it? You got to subtract, right? So this would be 4. Everybody see that? Right? If the whole side's 12, I take off the 8 on the for the top, that leaves 4 on the bottom. So if I did 8 to x would equal 4 to 6. Okay, this is one way to do it. I could have done the 8 to the 12, which would be the top to the whole side, would equal the top, which is x, to the whole side. which is x plus 6. So there's a lot of different ways to do these, but they're divided proportionally, so either of them work. So from here, this is times 2, so this is times 2. X should be 12. Or I could have cross multiplied and divided. Questions on that one? Okay, theorem 6, which doesn't have a name and the number's not important. What you need to know is what it says. It says if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So for this, you have to have 3 parallel lines, and they have to intersect 2 transversals. And when they do it, they divide it proportionally. So in this case, we've got BC over CD, so we went top right over bottom right, equals AF over FE, top left over bottom left. What happens if I wrote AF over BC? FE over CD. So I went left, right, left, right. Okay, so just like with the triangles, I could have gone bottom, top, so I could say EF over AF, and that would equal what? So I'm going bottom to top on the left-hand side. What would be bottom to the top on the right-hand side? Good. DC, C over B. So I can go left, right, right, left, bottom, top, top, bottom. I just can't crisscross. Like I can't say AF over CD equals BX over FE. That does not work. Questions so far? All right, so I've got 3 parallel lines and 2 transversals. It says if A is 2, B is 3, C is 5, then what is D? So what's one way to set up the proportion? So 2 over 3 would equal what? 5 over X or 5 over D. That's one way. Can somebody else give me a different way?
3 over 2.
3 over 2 would equal? D over C, which is 5. Good. Any other way?
2 over 5.
2 over 5. 3 over D. Good. Anything else? 5 over 2 would equal what? D over 3. So any of these work, because when I cross multiply each individual one, what happens? 2D equals 15. 2D equals 15. 2D equals 15, and 2D equals 15. So all of those proportions work. So my answer would be 15 over 2, which is 7.5 or 7 1/2. So just like before with the triangles and the proportional sides, if I'm asking for a side length, I expect to see it in decimal or mixed number form. Not rounded decimal though, but exact decimal like 7.5. Or leave it mixed number. Okay, so then B says if A is 4, B is 8, C is 5. And you're looking for C plus D. So what's one way to do it, Nick?
4 over 8 equals 5 over D.
And then what you'd have to do at the end?
Cross multiply and then add C and D.
Good. So I could do 4 over 8 equals 5 over D and then cross multiply. And then I'd add C and D, so 5 plus 10 is 15. Anybody know another way to do it? That works, but there's also another way to do it. What if I said 5 over X? What would that equal?
Over 12.
Good. 4 over 12. So I did the top over the whole segment, which would equal the top over the whole segment. Everybody see that? Yeah, you get the same answer both ways, right? So 4x would equal 60 and x equals 15. So both answers are right. Questions on that?
Wouldn't it be CB over AB?
So you always have to divide the part that the angle bisector is being divided by. So you're always going to take this side and divide it into two parts.
So then, like when you do CA over AB, then.
Oh, I'm sorry, that should be AD. This should be AD. Thank you. Right? I did CA over AD. Should equal CB over BD. So if I wrote AD over AC, what should the other side be? Good. So I did the top part of this bisected side over the top part of the triangle would equal the bottom part of the bisected side over the bottom part of the triangle. All right, so then this one says find x. So again, you're dealing with an angle bisector. So the angle's got to be marked as congruent. And there's a lot of different ways to do this. But this says 12 is one side, 24 is the other. And then x is the whole side there. So what's one way I could set this up?
12 over 10 equals 24 over y.
Okay, I could do 12 over 10 equals 24 over y. And then once I got that, I could do what with it? Add it to 10 to get the other side. So this would be 6 to 5 equals 24 over y. 6y would equal 120. He just said you could introduce a variable, solve for that part. So this would be 20. And then x would be 10 plus 20. Yep.
I get like how you solved it, but I don't feel like it's the first step of putting it in the equation.
So without, like, let's just say that the 10 wasn't even there. Or sorry, let's say the x wasn't there, right? Would you know how to set up your proportion that way? Like, I could say a couple of different ways. I could say 12 over 24 equals 10 over y, right? Top, bottom, top, bottom. Or I could say 12 over 10 equals 24 over y. So the outside part of it, right? The difference here is I want that whole side. So I've got to be able to find that missing piece, and then my last step's going to be to add it in.
So do 24 over x minus 10.
Yes. So y you could have made, yep, I could make this x minus 10, and then set it up as you did 24. So you're doing 24 over x minus 10 would equal 12 over 10, like that? Yep, that works too. Alexis.
If you go back up to the original way you're doing it, with like 12 over 10 equals 24 over y, with the second step, is that 24?
Yeah, that's 24. It
Okay,
says
I thought
6
it was
over 5 equals,
2y.
no, I just got sloppy. 6 over 4 equals 24 over y. Questions. So every single thing in this section is revolving around proportionality. Whether it's the triangles in the beginning, if it's a parallel line, it's going to divide it proportionally, or the 3 parallel lines and 2 transversals, they're divided proportionally, or the angle bisectors. Okay? Any questions overall?